Thank you very much, Father Thomas, for that very nice introduction. And of course, thank you to the whole Angelicum Thomistic Institute for organizing this conference, for asking me to speak. And yes, just as the fathers, I am both dismayed that I'm not with you in Rome on what I assume is a beautiful Italian March afternoon, and also very happy that technology enables us to still have this conference and to get together. So I'm gonna first make sure that this technology actually works, and hopefully you now, instead of seeing just me, you see Big Bang Cosmology and Christianity on your screen. And I don't see any shaking heads, so I'm going to go ahead and assume that this is indeed correct. Yeah, so Father Thomas asked me to talk about Big Bang cosmology and Christianity. So the Big Bang theory, which is at the root of the cosmology it describes, is our best scientific explanation for the origins of the observable universe. So that includes us, the planets, the stars, the galaxies. And what this talk is really about is this cosmology what it is teleology or purpose, and how to understand it in light of what we believe through revelation and through faith about creation. But before getting into Big Bang cosmology, I do want to take a few minutes to introduce some of its historical competitors, which actually also have present-day analogs. So the first alternative cosmology that we should consider is the mythological or pantheistic worldview that was commonplace in the ancient Middle East. So for those of you who have read the Numa Elish, you get a very engaging description of this kind of cosmology. So that's what I'm showing on the screen. So in this mythological cosmology, the cosmos itself is imbued with divinity. So if we're going to go back to the stars, the planets, the moon, the sun are all divine in some way or another. And so are, the chaotic waters and many other things that we think about as aspects of nature. So this kind of cosmos does have a beginning, but it's not necessarily an absolute one. So if we can go back to the Numa Elish, this word begins by the commingling of two watery principles. So it is historical, it has a beginning, but obviously these watery principles are there already. This historical aspect is something that it has in common with the cosmos described in Genesis. So our own creation story, where God creates and speaks the word and its inhabitants into existence. But the cosmology described in Genesis is also radically different from the mythological one in many ways. It doesn't seem to presuppose that there is something before creation starts. And in addition, if we look at Genesis 1, in many ways, it seems to be very conscious, polemical against the word where, the sun, the moon, the stars are gods. So in Genesis 1, the sun, the moon, the stars are simply spoken into existence and are there to keep time. So this means that the biblical cosmos is not ordered by the doings and personalities of different divinities, but it instead is ordered and run through different principles, so we could call them laws. The second cosmological competitor to the Big Bang theory is a cosmos that is so well ordered, so law-abiding, that it doesn't really change substantially over time. Or if it does, it happens as regular cycles. So the Aristotelian cosmology, the one that was assumed by St. Thomas Aquinas, is one example of this. So are many Eastern cosmologies. And also the cosmology that emerged after the scientific revolution, so the Enlightenment cosmology, which often is described as some sort of mechanical clockwork that once you set it going, it just runs the same way throughout eternity. There's actually also a more recent version of this, the so-called steady state cosmological model of the mid-20th century, which is the most recent competitor of the Big Bang theory, which acknowledged that there was things moving away from one another in the universe. Maybe there was even expanding, but still kept the cosmology that it didn't change over time, but you basically just filled in the gaps as galaxies were expanding away from one another. So all of these cosmologies have in common that there's no real history. There's no sort of natural development or unfolding over time. So if we're to sum up these sort of cosmological competitors, we have the pantheistic or mythological cosmos, which is historical, but not necessarily expected to operate by laws of nature or to display, or in other words, to display predictable and well-ordered, changes over time. And that means that it's not very compatible with a scientific project, which relies on these patterns and laws being there. On the other hand, we have the Aristotelian or Enlightenment cosmologies, which operate according to fixed laws, but do not readily evolve or unfold over time. They're naturally eternal. Now, the biblical worldview is in contrast to both. It is intrinsically historical and it's law-abiding. And so is the contemporary Big Bang cosmology, which is what I want to get to next. So the science of cosmology, which is really a field that straddles physics and astronomy, has revealed that we live in this really large and very old, but not infinitely old, universe. So the visible universe, which is the part of the universe that we can see, is 93 billion light years across. By comparison, the distance from Boston to Rome is about 20 millilight seconds, and the distance from us to the sun is about 8 light minutes. So this is just unfathomable, the kind of distances we're talking about. And when compared to the kind of length scales that we are used to, the visible universe doesn't seem that different from infinity. And this whole almost infinite universe, almost about 14 billion years ago, this whole expanse fit into something in a very small fraction of the size of an atomic nucleus, equally impossible, I think, to actually imagine. So this very compact early state of the universe, this fraction of an atom kind of size, and its subsequent expansion is what we colloquially refer to as the Big Bang. So I'm going to continue sort of reviewing the different stages of the Big Bang, but before doing that, I want to talk a bit about this sort of initial part of the Big Bang, when everything begins, and how that compares to our understanding of creation. So when the idea of the Big Bang cosmology was first introduced in the 1930s, it was introduced by Georges Lemaitre, and it was generally greeted with a lot of skepticism by most of the scientific community. It was, however, rather quickly embraced by the Pope as a really excellent scientific model of the cosmos. So from a historical point of view, why this skepticism and why this enthusiasm? Now, the prevailing cosmology at the time was, as I already mentioned, an inheritance from the Enlightenment, from the scientific revolution, when Newton and others developed this amazing mechanical models of the universe that seemed to describe the universe really well. And that seemed to suggest that our universe was something like a very well-functioning clockwork, which had always been operating according to the same kind of mechanism and always would be, barring any supernatural intervention. So the intuition of most scientists who were not supernaturalists by the early 20th century was that the universe was constant in time. And we can add to that there had been a lot of astronomical developments in the decades leading up to Lemaitre that had shown that our star was just one of many, and that it seemed like on large scales, the universe was approximately the same wherever, in whatever direction you looked. So you had this very strong intuition of a universe that's constant both in time and then homogeneous in space. So it's not so strange then if you have this very strong concept or strong worldview, strong belief in this worldview, that Lemaitre just having this brilliant idea was not sufficient to sway people into his camp. But as time progressed and more astronomical observations came in, evidence really began to mount that Lemaitre was right, and that we do live in an expanding universe, and one that started from something very small and very compact. But yet, there were many who continued to not accept his conclusions. And not an insignificant fraction of these skeptics thought that the whole idea of the Big Bang sounded suspiciously religious. And it really didn't help that Georges Lemaitre was, in fact, Father Lemaitre, which you can see on the screen in front of you, a Catholic Belgian priest. This may also help to explain the Pope's enthusiasm. And by 1951, so before this was a fully established theory within the scientific community, Pope Pius XII declared that Lemaitre's idea and theory provided a scientific validation for Catholicism and its understanding of creation. Lemaitre was actually not very happy about this, and gently rebuked the Pope for using his scientific theory to try to prove creation. And he eventually convinced the Pope to stop using the Big Bang theory as evidence for the theological truth of creation. That is the truth that the whole cosmos has a beginning in time and was created out of nothing by God. But why do I think this is right? Superficially, doesn't it seem like the Big Bang is actually a description of the universe coming into existence from nothing, just as we believe by revelation? Well, the Big Bang theory describes the beginning of the universe and how it unfolded in time. But it doesn't actually describe how the universe came into existence. Nor does it allow us to rule out that there is an eternal material order, an eternal cosmos, within which the Big Bang occurred. One could imagine, and many philosophers and scientists have, that our universe is only a bubble, so sitting on a larger superstructure, or maybe it's something that just popped into existence out of a quantum field. In both cases, you have something else that's there before that could, at least in theory, be eternal or infinite in time. So the Big Bang as a scientific reality, I would say it is a beautiful and really powerful icon of creation, but it is not creation itself. And in many ways, we're actually not in a very different place compared to St. Thomas Aquinas, who put quite some energy into address whether it was possible to prove that the universe has a beginning or prove that it is infinite in time on philosophical grounds. So in his time, many Arab Aristotelians, such as Avicenna and Averroes, as well as Aristotelians that were contemporary to St. Thomas in the Western world, thought that you could prove, or thought that they had proved, that the word was eternal and that creation from nothing was impossible. So you had people who thought they could actually philosophically and in some sense pre-scientifically proved that the universe was eternal. By contrast, you also had theologians, philosophers like St. Bonaventure, who thought he could prove that the world must have had a beginning. And you can find modern adherents to both positions. St. Thomas Aquinas demonstrated really beautifully in multiple places, including in the Summa, that neither is actually possible to prove from a philosophical point of view, and that it is only through revelation that we know that the Word has a beginning. And even in the age of Big Bang cosmology, this remains true. But let's return to the exposition of the Big Bang cosmology, which we had begun before this little interlude. So as the universe started to expand from this initial hyper-compact and very hot state, it cooled down. And as it cooled, more and more complex particles could stick together. And atomic particles, like protons, became stable within a couple of minutes of the beginning of the Big Bang. During the subsequent 18 minutes or so, the conditions were just right. You just had the right temperature for fusion. So this is the sticking together of protons and neutrons to form larger nuclei than the proton, which is the nucleus of the hydrogen atom. And some of the protons and neutrons fused together to form helium nuclei and a tiny bit of lithium. But the universe continued to expand, and it rapidly moved into a place where it was too cold to continue this fusion, and pretty much the only elements that were formed in the Big Bang were hydrogen and helium, and there were just no other elements around, no carbon, no oxygen, and so on for a very long time. About 400,000 years after the Big Bang, the universe has cooled down enough that electrons could start staying attached to protons, forming complete atoms. So an atom, when you think about the elements, consists of a nucleus of protons and neutrons, and then an electron cloud around it. But these electrons can be knocked off by photons, by light particles, if they are energetic enough. And up until 400,000 years after the Big Bang, these light particles or photons were so energetic that they just continuously knocked off the electrons, and there was no way for atoms to stay intact. But this combination of nuclei, atomic nuclei, and electrons at 400,000 years after the Big Bang marks the time when matter on the one hand, so the elements, and light on the other started their independent existence. As someone who loves going back to Genesis, I cannot really ponder this scientific truth without at the same time thinking about Genesis 1:4, where it says that God saw that the light was good, and God then separated the light from the darkness. And modern cosmology, I think, has given us a second really powerful icon of how God creates, with the Big Bang itself being the very first one. This era of combination of electrons and protons to form atoms also provides us with the very first picture of the universe. So when the light was released from the matter, it started a journey through the universe that has continued through this day. And we can still see the faint afterglow of this event, which is the cosmic microwave background radiation. And this signal was first discovered in the 1960s. And when it was the sort of final conclusive piece of evidence for that Lemaitre had been right about the Big Bang theory. Now, one of the things you can see if you look at images of the cosmic microwave background is that it's structured. It is not a smooth kind of radiation, but you have sort of overdensities and underdensities of photons if you look across the sky. And this means that sometime between the Big Bang itself and 400,000 years later, when these photons were released, some structure had already begun to develop in the universe. We no longer had sort of a smooth bubble expanding. And the little ripples that we see in these images of the cosmic microwave background radiation, those are the seeds of what would become clusters of galaxies millions and billions years later. One of those clusters would eventually contain our own galaxy, the Milky Way. A few 100 million years after the release of the cosmic microwave background radiation and after the Big Bang, the universe had cooled down even more. It had cooled down enough for some of the gas, this is some of the hydrogen that formed in the Big Bang, to start imploding in on itself under its own gravity. And this is how stars form. So the first stars started forming, as I said, talking a few 100 million years after the Big Bang. And that totally changed the kind of cosmos that we lived in. Up until then, the universe had been dark. And it's actually referred to as the Dark Ages. That's the technical term. And suddenly, the universe is relit by the stars. These stars very quickly went from quiescently burning stars to exploding in something analogous to supernovae, which we see is how massive stars die today. And through these supernovae, they spread the whole periodic table of elements into the universe for the first time, enabling, so now we have things like carbon, oxygen, and iron in the universe. And this means that we have the material to form, for example, planets, to form things like water and organics, so the things that's needed for life to be able to exist. There are several things that stand out about the Big Bang cosmology, especially if we contrast it with some of the competitors that we talked about before. First of all, as I've already hinted, it is historical. So we live in a cosmos that has a beginning and that has a direction. It is unfolding over time. So the cosmos, though, is not just different compared to how it was a few 100,000 years after the Big Bang, it is also more interesting. So, once there was this almost homogeneous just bubble of things expanding out. Now there are galaxies, stars, planets, molecules, even life. And these arrived over time, building on past events. A second thing is that our universe unfolded through and by laws of nature. One of the ways we can see this is that there are enormous simulations of the cosmos and how it unfolded over time. And these simulations can reproduce many of the structures and processes that we observe with our telescopes. So one of the advantages in astronomy is that if you look really far away, you're also looking back in time. And that means that we actually have observations of how the universe changed over time, going back to at least sort of a billion years after the Big Bang. So going back around 13 billion years. Now, these simulations, which are amazing feats of science, work as well as they do because this whole development, this whole directionality of the cosmos depends on a pretty small set of laws of physics. And when we combine those laws with what we understand about initial conditions, things that we learned, for example, from these images of the cosmic microwave background radiation, that enables us to predict quite well how the universe changed over time. Now, a third point is that however impressive these simulations are, they're still quite far from being able to model the cosmos from first principles. And there are still many fundamental aspects of the cosmos that are still very mysterious. Perhaps most famously, the majority of the universe is actually invisible to us. It consists of so-called dark energy and dark matter, both of which we don't know exactly what they are. So on the one hand, the universe appears highly ordered, but it is ordered in a way that is still beyond our current understanding. So the overall cosmology, so think about the universe developing over time, is then characterized by a combination of historicity, orderliness, and patterns that point towards laws that are not yet grasped or fully understood by us. The same thing is true if we zoom in on a single planet that is our own. So about 8 billion years after the Big Bang, dust grains, so basically sub-micron-sized dust grains that formed as a part of these supernovae explosions, were swirling around our young sun, and they started coagulating together to form larger and larger bodies, and eventually they formed the Earth. So the Earth was then populated by water and by simple organic molecules, probably in large part being delivered to the young planet from space. And sometime between about 3.5 and 4 billion years ago, these simple molecules began to combine into the large and complex ones that we associate with life. So molecules like RNA and proteins and cell membranes. We don't yet understand the precise process through which this happened. But what we do know is that the chances that carbon and other elements combined completely by unguided chance into functional RNA and DNA chains and proteins are really too small to take seriously. This suggests something really interesting, which is that on a planet like the Earth, the chemistry has a trajectory, and it has a trajectory towards life. This does not necessarily, or I would say perhaps even likely, involve a supernatural or miraculous guidance. Rather, it means that there seems to be something inherent in the laws of chemistry that enable the building blocks of life to assemble prebiotically. As I said, we don't yet fully know these laws, and there are no guarantees that we ever will. But the observation that a transition from simple chemistry and simple molecules to the building blocks of life happen on at least one planet is already very suggestive that there is really directionality built into the chemistry in the cosmos. And I would say that this is the intuition of the scientists, both chemists, the scientists that work on origins of life and on finding life on other planets. This is true for chemists that try to deduce the pathways from chemistry to biology. So if there wasn't, if you didn't get an evolution from these simple molecules to these very complex ones to life pretty frequently, there's no way we would actually be able to figure out what the pathways are, what the laws are, since the scientific method does rely on being able to experiment and being able to repeat a process over and over again. That there is something that causes chemistry to turn into life is also the intuition of astronomers. They're looking for life on other planets. Again, if we didn't think that this was something that happened pretty frequently, it would not be very useful to be spending a lot of telescope time and looking for signs of life on some of the thousands of exoplanets that have now been discovered. So detecting life on even one other planet would provide scientific evidence for an argument which we already hold to be true by faith, which is that the universe, was created to be filled with living things. So we have already seen then that there are several signs of convergence between the cosmos described in Genesis and the cosmos described by the Big Bang cosmology. Both have an emphasis on the beginning and on creation unfolding in a series of steps. But I think it's only fair then to ask if there are other aspects that should trouble us or that challenge Christian orthodoxy about creation and our place within it. So one fairly common criticism of the biblical narrative is that it's so centered on the earth and on humans. Now, this may have been reasonable in a world where the earth comprised the cosmos, as it seems to basically in the cosmos described in Genesis. But to many, this narrative became less reasonable once we discovered that our cosmos is very large, perhaps infinitely large, and we seem so very small in comparison. This train of thought, I think we associate with modern cosmology, but it is far from new. Or the psalmist was exclaiming, when I see your heavens, the work of your fingers, the moon and stars that you set them in place, what is man that you are mindful of him, and the son of man that you care for him? So compared to humans, there were always things that were bigger, and even the ancient cosmology seemed exceedingly large compared to us, to the people who inhabited it. But I would say if there's one thing that biblical revelation tells us, it is that how big something is and its significance are not the same thing. Now, it is through the incarnation of God, first as an embryo and then that grew into a baby, that the whole world was saved. And I think in general, we should be very skeptical of arguments that use the size and the vastness of space as an argument against a personal God deeply interested in our doings. We could as well turn it around and state that the size of the universe actually shows the superabundance of God's gift. I mean, what a garden he has created for us. And this too is what the psalmist seems to realize as he continues already in the next verse, that yet you have made him little less than a god, crowned with glory and honor. So if the size of the universe does not directly threaten our belief that God is intensely interested in humans and the planet we inhabit, how about the location, our location in the cosmos? There's a common story told by skeptics of the Christian story, which is that as history unfolds, we have gradually moved away from the cosmic center to its periphery. So in the pre-scientific age, before Copernicus and Galileo, we believed that the Earth was the center of the universe. And in that era, maybe it made sense to believe that the Earth was created especially with humans in mind, and that humans, being the most intelligent creatures on this planet, were the pinnacle of creation, and that any creator would have a special care for these creatures and want to have a special relationship with them. But then Copernicus, Galileo, and Kepler moved the Earth from the center into orbit around the sun, which seemed bad enough. But then modern astronomy moved our sun from the center, from the center of the world into an orbit around our galaxy, and actually quite far out in the galaxy. And then our galaxy turned out to be just one of 100 billion others. And now we know that these galaxies are not just full of stars, but also full of planetary systems. And if we're just one word of many, why would God take such care in making our world a garden? And how can we believe that the creature he placed here on this pale blue dot, he somehow loved enough for his son to become incarnate as one of them? This does seem to pose a threat to Christianity as traditionally understood. Though I think not. If we think about why the Earth resides where it is, it's pretty much because the laws of nature would not have it sitting at any of the places where previous cosmologies would place it. And God seems to really take delight in letting order unfold according to these laws in our cosmos. So, for example, if the solar system was placed at the center of the galaxy, we would be sitting inside a supermassive black hole which is not conducive to life. Or if the Earth was sitting at the center of the solar system, well, it would be a bit too close to the sun for comfort. So if we're looking for God to reveal himself, primarily through miracles, our location in the solar system and in the galaxy might be somewhat disappointing. But that's not how God has been typically understood to reveal himself through creation. Whether you read the Psalms or the Church Fathers, it's the amazing order of the universe that reveals God as its intelligent creator, rather than any disruptions in that order. So again, the psalmist declares that the heavens declare the glory of God, the firmament proclaims the works of his hand, day unto day pours forth speech, night unto night whispers knowledge. And as our understanding of the universe has increased, we have uncovered increasing layers of order. We know now that planets form naturally whenever a star forms. And one day, I hope we will also know the laws that describe under which conditions life originates. A third possible contention between the Big Bang cosmology and biblical cosmology concerns the specific steps that creation unfolds through in the Bible and the steps it unfolds through within the Big Bang theory. It would seem like, if nothing else, the Big Bang theory threatens a literal reading of the Bible. Before going into details, I do want to quickly note that clearly Pius XII did not think that was the case. And it sort of comes down to definition of the word literal. If by literal we mean reading Genesis like a science textbook, then there is a very real conflict. But even a cursory look at the content and structure of Genesis 1 should dissuade us from thinking that this is a reasonable reading. I mean, if we start with something like Genesis 1:13, we read, evening came and morning followed the third day. So we're on the third day. And then God said, let there be light in the dome of the sky to separate day from night. Let them mark the seasons, the days and the years, and serve as lights in the dome of the sky to illuminate the earth. And so it happened. God made the two great lights, the greater one to govern the day and the lesser one to govern the night, and the stars. I would postulate that also a few thousand years ago, it was quite clear that the concepts of day and night depended on the existence of the sun, and yet the sun is nowhere to be seen until the third day. So a textbook reading seems ruled out. Now, if by literal we instead mean what the author intended, then the conflict between the biblical and scientific accounts is much less clear. The author of Genesis clearly believes that the universe as he knows it is a loving creation of God. And there's nothing in contemporary cosmology or astronomy that contradicts that. The human author also clearly believes that there's order in the cosmos and that this order is intentional. I would say that contemporary astronomy would be impossible without that. The human author clearly did not know the size and age of the universe as well as we know it today. And I would say there's really no hint of the kind of cosmological distances that we now know are true in the Bible. One of the things we can conclude from that is that an understanding of modern cosmology is not essential for salvation. But that does not mean, I think, that the details of the universe are unimportant to know about, or that knowledge of the Big Bang is devoid of meaning. I would actually argue that the Big Bang cosmology goes far beyond not threatening our understanding of a biblical cosmology, but rather provides multiple spiritual aids. We have already heard about some of the amazing icons provided by the Big Bang cosmology, the most impressive one being the Big Bang itself. While not itself the moment of creation, it's difficult to think about a better icon of it. And furthermore, an historical cosmos undeniably serves as a reminder that it is strange that the cosmos exists at all. keeping our contingency ever before our eyes. Now, the philosophical argument for the existence of God, for example, from contingency, does not depend on whether the universe is infinite in time or not. But I would still argue that it becomes more intuitive, that there must have been something creating the universe and something holding it up when you have this great icon of its beginning. And that we are in a rather privileged position that way compared to, for example, people living during the Enlightenment. A second aspect of the Big Bang cosmology is just how law-driven it is, and how it shows that natural laws allow for there to be unfolding with time. And this law-driven unfolding really endows creation with a beautiful dignity. It enables it to take part in its own development through secondary causation over time. And in that way, the evolving cosmos becomes an icon of God's goodness and delight in sharing his creative powers and governance of the world, both with us and with things that are not conscious themselves. So one of my favorite examples of this is our very recent discovery of these dust disks around young stars and the dark lanes that we see in them, which comes from planets forming in these dust disks right now, just through the laws of nature operating on these disks. Now, third, a historical cosmos allows for things to exist over time that could not have coexisted in the same time and place otherwise, allowing for aspects of God's glory to exist or to shine through as the universe develops. Now, it would not have been very good for a living planet to be sitting inside of a burst of star formation. The radiation from that would have killed any surface life on any nearby planets. But these bursts were absolutely essential to create the galactic environment we live in, and all the elements that we needed for our planet to form. And they also make for a really glorious and beautiful event to look at. And finally, I would say that by creating a universe with a beginning and with a possible infinite expanse, God has provided a really beautiful icon of the infinity of his power. And this might be reason enough for creating the universe in such a way as he has. Perhaps he also wishes us to use this vastness of space to stretch our minds, providing a contemplative path from science to him, and fully grasping, what infinity is or what all-powerful means is really not possible for us. The fact that we cannot comprehend God or his plans can be cause for doubt that something like him could even exist in the first place. I think it's beautifully providential that his cosmos provides an array of natural things that are also too big and too complex and too powerful to really wrap our head around. If nothing else, that should convince us that just because something is too big for us to grasp does not mean that it does not exist. The universe is too big for us, and it is definitely there. So to conclude, we live in a universe of unimaginable expanse and age. It is an evolving universe where new structure and things emerge over time with a clear direction. The origin and evolution of our universe, as revealed by science, has often been put up in opposition to the creation described in the Bible. My proposal is that rather than threatening our belief in divine revelation and providence, these scientific discoveries have provided us with new and powerful icons of God's love, of his generosity, his creativity, his authorship, and his power. And I will stop there for any questions.
Right. Thank you very, very much, Dr. Öberg. It looks like we have a few questions in the chat. So I think the way we'll try to do this is I will call on you, and if you can turn your microphone on and read out your question. And so because of that, I apologize in advance for any names that I pronounce. And I continue to apologize to Dr. Öberg, who I have asked many, many times how to pronounce her name and continue to change it in my head, and I apologize. So the first comes from, I believe, Spiridon Vutrofinis.
Yes, hello, thank you very much for your very inspiring, very informative presentation. I have a question about the eternity of laws. You said at the beginning that there is a contrast between the Eastern traditions and Aristotelian tradition. And according to the Aristotelian tradition, the laws of nature are eternal, as well as the species that inhabit the universe. Is there any evidence that laws of physics change? I mean, I have heard that many times, many people are talking about that, but I don't know anything really relevant about that. And is there any evidence also that natural constants, velocity of light or gravitational constants, or things like that change?
Yeah, thank you. That's a great question. So I'll have a first stab at it, and maybe Father Thomas wants to supplement. So starting with your second question, so when it comes to fundamental constants, people have tried to look back in time and see if there is any evidence of change over sort of billions of years, and there's no evidence. So this doesn't mean we can rule it out, but there's no evidence of changing constants to date. As for the laws, there's the sort of overall answer is the same. That I think the amazing thing is actually that it seems like the laws are constant, and yet that leads to this incredible emergence of new structures and new processes. The only caveat to that is that at the very beginning of the Big Bang, in this like super dense state, it seems like the laws were coupled in different ways compared to how they are today, and sort of separated out from one another very, very early on in the Big Bang. Now, the idea there, though, is that still it's not like the laws themselves change, but it is really how, if they're merged or separated, does depend on what kind of sort of state you're in. But I'll let Father Thomas supplement that, since he's the actual physicist in the room.
I don't have a whole lot to offer on that, I guess, but yeah, no. From what I understand, I mean, there are people who have proposed the possibility of the changing of the various physical constants and argued for why that might be helpful for various problems, but there's no observational evidence thereof. And yeah, the phenomenon that Dr. Öberg is referring to is kind of the idea that many of the forces that for us are very distinct in the way that, so the way that electricity and magnetism is very obviously different than the way that the forces of the nucleus work. At that dense, compact state of the Big Bang, they were somehow the same. There's a mathematical pattern by which at lower energies they end up acting differently, where the force that was at these higher energies, sort of one thing, can have multiple effects at lower energies. So thank you very much for your question. The second question, I think I believe it's Jose Guillerme, and he asked me to read it for him. So, and the question is, he would like to hear your thoughts or appreciation of the anthropic principle in the form that it takes in a variety of writings. He references particularly John Barrow and Frank Tipler. And he would like to know what your thoughts on it in general. Is it helpful? Are there problems? So just what are your thoughts on the anthropic principle?
Sure. So first of all, so the anthropic principle, what it refers to is that the constants that we were just talking about, these constants that are so important for basically governing how the laws of nature works, these seem to be very well tuned for having the kind of universe we have where stars, planets, and life can exist. And if you start changing those constants in models of the cosmos, but let's say 10, 20%, you go from having this really interesting universe to having something that basically collapses in on itself even before it got started. And we don't know why these constants are tuned the way they are. There's not something that follows from the laws of physics as we understand them. So that's then there's sort of three basically possible explanations for that are not, by the way, mutually exclusive for why we get this what looks like a very fine-tuned universe for having beings like us in it. One is that it was purposefully created to bring forth stars, planets, and life. And that's where it's sometimes used as an argument for God's existence. Another option is that there is some sort of super law of physics that we have not yet discovered that basically forces these constants to take on the values that they have. And the third option is what I was alluding to in the talk, that we don't know if we're the only universe. We might be one of an infinite number of universes, and all of these different universes, have different versions of our laws with different constants of nature, and we just happen to be in the one where things got it right. And as I said, these are not mutually exclusive. All three could be true. So I don't think it on its own it's not evidence for God's existence, but I think it is, again, something that's more of a suggestion or an icon of his goodness. And I said, what more would I say? The other two ideas, that this is either coming out of some unknown law of physics, or that it's coming from having this billions of universes, those two are currently statements of belief. They are not something that the scientific method has shown to be true. So this is a very speculative realm, and I think I'll stop there.
Very good. So let's see. The next question from I believe it's Jeffrey Woolard. If you'd like to
yes, thank
read
you
your
very
question,
much.
Yeah.
Thank you very much, Dr. Ober, for your talk, especially at the end, how you read, your reading of the Book of Nature and reflection on the sort of icon of God's providence and goodness. So these days I'm reading Simon Conway Morris's books, particular Life Solutions from 2003. And he goes into quite some detail. I'm still kind of plotting my way through the beginning. It's kind of encyclopedic. About in the beginning, he's talking about the bias stereochemistry in terms of isomers in carbonaceous meteorites. They tend to be just totally uniform compared with life. There's just huge biases in the stereochemistry of actual, living organisms. So I wonder if you've kind of maybe have some, if you're up on the literature because of your research, and what are your thoughts on that? And if there's been any, the book's from 2003 and we're in 2021, so maybe there's been some important discoveries or ongoing thought.
So I haven't read the book, I guess is the first. So would it be possible for you to sort of specify your question a bit further if there's something like specific that you're curious about?
Have we discovered any, have we measured any organic molecules where there is a lot of bias in the stereochemistry, or again and again, are we confirming the sort of uniform distribution of things that come from space?
So I don't believe there's a uniform distribution in things that come from space in almost any aspect. So there are many different ways that molecules as well as elements can differ from one another. Well, you can have different isotopic compositions, so more carbon-13, less carbon-13. There's a wide distribution of that in space. When it comes to how the molecules are put together, so what kind of organic molecules we see, there's also a wide distribution of that in meteorites. I think one of the things that maybe was starting to happen when this book came out, but it's probably been more in the past decades, is the realization that some of the molecules that can be left or right-handed.
Yeah, this is what he's picking up.
Also in meteorites, there seem to be excesses in one direction or the other that are actually quite difficult to explain why they're there. So that's one thing, that there is some tentative evidence that potentially a leaning towards right or left-handedness could have been seeded by molecules from space. Now, I think that's really interesting, but I would say where current origins of life studies are, they don't necessarily rely on starting with having an excess of either right or left, but think that maybe that's something you can sort of by chance develop later on. Having only right or left-handed molecules increases your stability and the ease at which you can build up structure of very long molecules. So it's definitely a good thing to have around. But it's not obvious there's absolutely necessary to get this prebiotic chemistry started. And I think to add to that, I think one of the big developments since that book is that several of the steps in going from these small molecules into biomolecules seems to be working better than people had expected, or happen under more sort of realistic conditions than people maybe had expected. So while we're still very far from having a theory of origins of life, I would say some of the hurdles that were being put up about why this should be really hard have actually been overcome. So we're at least moving in the right direction, and have during the past 20 years. So no, thank you for the question. And I hope that at least addresses some aspects of it.
Thank you.
All right, I think we have time for one more question before we take a brief break. So I guess James Gordley, if you could read your question, or yeah. Oh, okay.
I'll be there. Here I am. Here I am. I'm sorry about my clumsiness with this machine.
No worries.
Okay, there I am. Now, my question is this. Doesn't the formation of the universe support Aquinas' proof by design? Which is to say, you have to start with the right stuff, which and it's subject to just the right laws in order to form protons, electrons, stars, life, and so forth. In other words, something has to be there such that when it cools, you get the protons and neutrons, such that when things cool still more, you get atoms, such that when the stars form, they cook in its belly, such that eventually you get DNA sequences. Isn't that proof by design? Now, you might make the same answers that you did to the anthropic principle. You might say, well, maybe there are it's a super law that dictates that stuff should exist in just the right way that eventually it forms this stuff, but that doesn't get around the proof by design, because the question is, why should a law exist such that it will eventually produce life? Or you might say there are so very many universes that somebody rolls dice, and no matter what the odds are, sooner or later you get this one. But now you're imagining a dice thrower who throws dice to determine whether there should be such things as elementary particles, quantum laws, and so forth. So you'd have to imagine a dice rolling machine, which had the property of producing infinite universes, plus the property of producing one like ours. And wouldn't that support the proof by design?
I mean, I am very sympathetic to your line of reasoning. I would say my intuition is definitely in the same direction. I do think the ordered universe that we live in, it is, let's say, there's no other satisfactory explanation as far as I'm concerned for it. And the kind of sort of brute fact kind of explanations that people sometimes try to throw our way, I don't actually see the difference between that and no explanation. So I don't really have the philosophical chops to trust my own intuition there. And again, I would kind of like to hand it over to Father Thomas, but my intuition is definitely in the same direction as yours. So thank you for that question. But I don't know, Father Thomas, if you want to comment on it with a more philosophical training than I have.
I think there's I don't want to take over too much or too long, but I think there's a way in which one of Aquinas's classic arguments is about the order. There are different ways you can talk about order in different ways that Aquinas thinks about order, and the way that order is manifest in the natural order. there's order between one effect acting on another. There is order between sort of higher things and lower things, and there is sort of what he talks about as a teleological ordering as well. That there is a way in which one aspect of nature tends to do a certain sort of thing, and it works well with another aspect of nature. I think in some ways the general pattern you're talking about, when we look out and see how things are well designed, gets close to something like the Aquinas's argument from the fifth way. But in a certain sense, his argument isn't built on the particular details. It just so happens, that he thinks there is an order, and so that needs an explanation. So any order whatsoever, however complex or not, requires an explanation. The question of whether you can get around that by positing, previous structures that would then explain this particular order, that's not something he considered directly. But I have a feeling that you could argue, I'm fairly confident you could argue that you don't actually escape his conclusions if you keep pushing back on things. So.